Welcome to K2 Concept YouTube channel, and with you is Dave Kome, and I'm going to be taking you on an interesting part in mathematics, which is tied to mathematical method. And we're going to start with differentiation, and I'm going to be taking you on one of the important rules in differentiation, which is product rule. I believe every one of you understand, or you have one way or the other encountered this rule called product rule, but you might have been finding it difficult on how to implement the rule. So first, before we go into the product rule proper, I'm going to be showing you how to differentiate a polynomial. Now let's take, for example, that we have a polynomial function of this kind, y equal to x raised to power n, and we are asked to differentiate this polynomial. To do this, then we are to differentiate y with respect to what? X. That is, the y with respect to what? To the x. Now, in differentiating polynomials, the power of the polynomials comes down to multiply the original polynomial given to us. That is, the original polynomial given to us here is what? X to the power of what? Of n. But after the multiplication, the function, that is the polynomial function given to us, will not remain the same again. The power will reduce by what? By 1. That is when we have n multiplied by x to the power of what? N minus 1. To this effect, we can differentiate as many polynomials as possible. But there is a difference, or we have a challenge whenever we are given a constant to differentiate. For example, you are given y equal to k. Now we can see that k is a constant. Why is k a constant? Because there is no x there. So if you are differentiating y with respect to k, with respect to x rather, and we are not seeing x on the right hand side, it simply means that what you are seeing on the right hand side is a constant, because it does not contain the variable x. And how do you differentiate a constant? Let's take note. Anytime we differentiate a constant, then the result of the derivative will give us what? 0. Now, this is how to differentiate a polynomial. But we still have other functions we come across when differentiating. And some of these functions are what we call trigonometry functions, exponential functions, logarithmic functions, and so on and so forth. Now, because of this class, I'm going to be explaining how to differentiate trigonometry function and exponential function in a short while. Now, if I'm giving cos, for example, and I'm asked to find the derivative of cos, simply put, the derivative of cos will give us dy dx, which is what? Minus sine s, simply put. And if it was sine, we are asked to differentiate, that is y equals to sine, then dy dx will give us cos x. Then also, if you are given an exponential function to differentiate, for example, e raised to power x, to differentiate an exponential function, the derivative remains the same. We have exponential of what? Of x. Now, these are the way to differentiate some certain word function. And also we have lastly logarithmic function. Logarithmic functions are functions of this form, ln x, or on the other hand you can see it as log of x. Take note, ln and natural log are the same. That is, if you see ln x and you see log base e of x, these two are what? Are the same. That is, if I'm to differentiate ln x and I'm also asked to differentiate log x, the result of this will give us dy dx will give us 1 over x. Now, if I know all this at my fingertips, then it becomes so easy to differentiate all these problems. Now, let's take note of this, that this result of trigonometry function, exponential, logarithmic, and the others are obtained from a table we know as table of what? Standard derivative. table of standard derivative, although they can be obtained using the first principle of differentiation. If you can, as time goes on, I'm going to show you a video on how to use the first principle method to obtain the derivative of trigonometry function, exponential, logarithmic. Now, let's go back to what we have for today, product rule. Now, from the word product, mathematically we know that anytime we hear of the word product, it means multiplication. Now, rule are things that we must obey. That's just like a law that we must obey. Now, product rule is going to be applicable, or a rule that is going to be applicable whenever we see two functions multiplying themselves. If two functions are multiplying themselves, then the applicable or the right rule to apply is product rule. Take note, not only multiplying, these two functions must be functions of the same variable. Like this, we are seeing u being a function of x and v also being a function of what? Of x. And to do this differentiation, there is a formula. Now this formula is universally accepted. And how do we get that? We are differentiating y with respect to the variable x, in which the two functions are also depending on. So we know that y is the dependent variable and x is the independent variable. Now we are having two other functions depending on x. So to find the y, dx, we need to first of all obtain the derivative of each of those functions with respect to the to the independent variable x also. And applying product rule, this is the formula: u of x dv of x dx plus u of x du of x over dx. Now, also in a short form, you can see them write it like this, or in other textbooks you see it like u dv plus v du. It's still the same thing. Where d that you are seeing there means derivative. Another name you can call it differentiation, or you can say differentiate u. That's what they are saying on this part. So take note of this. Now, the functions we are going to be seeing majorly in this course, and as time goes on, we're going to be seeing functions like one, power functions. And another name for power functions are called what? Polynomial functions. And if you look at the beginning of this video, I explained how to differentiate polynomial functions. So that is the same thing as power function. 2, we have functions like exponential functions. 3, we have something like logarithmic functions. 4, we have something like trigonometry functions. Now, if you are just watching this video, I have explained, or I showed you some of these functions. So the first one we differentiated was polynomial function. So if you are doubting or you don't know what a power function is, the first one is a power function. Then the next one we differentiated the cos, the sine, the secant, the cosecant, the cotangent, the tangent itself. They are what? The trigonometric function. And exponential function was differentiated here also in this video. And I said anytime we differentiate exponential, we get exponential. It does not change. Take note, it's always with respect to what? A variable. We can call it x, we can call it t, depending on the independent variable given to you in the question. Now, for the logarithmic function, I also explained that. I said logarithmic functions are the ones that appear when you see the type of lim. You see log. So these are logarithmic functions. Take note of that. Now, in the subsequent videos, I'm going to be explaining some other things to you. Now, if you look at these functions I just explained now are in their natural state. But as time goes on, there will be a stage in which they will not be in their natural state. There will be an adjustment in the function. Then when that occurs, there is a rule to apply. So stay tuned. You are going to watch the video. I'm going to explain how that can be solved. Now let's go back to what we have. let's go back to what we have. Now, we are having an example. Find the derivative of this. Now, this is a question given to us. And the first thing I'm to do is to check, what do I have on the right hand side? How many functions do I have present? And we can see clearly that we are having only two functions. And if you can see, the first function we are having here is the power function. And the other one we are having is the what? Is the trigonometric function. And another thing we can see happening between these two functions is that the two functions are what? Multiplying each other. And we say that anytime two functions are multiplying each other and we are asked to find the derivative of this function, then the only rule we are to apply is what we call what? The product rule. The product rule. Now, and to apply the product rule is very simple. We saw the formula stated earlier on. The product rule is very easy to apply since we have understood that the rule to differentiate this function is what? Is product rule. The first thing you do is you represent each of the function with a letter. You can call it let u become the first function, that is let u equals to the power function. Then let v equal to the what? Trigonometry function. You can use any letter of your choice. So, but now, oftentimes you see textbooks, when you read textbooks or you watch other videos, you will see that you see them use u and v. Does not mean that is the only variables you can use. You can use other variables like t. You can use other variables like a and b, depending on what you want. Now, if this is u, that is our power function is u, then our trigonometry function is v. Now, the next thing we have to do is these two functions that we have represented with u and v, we have to differentiate them with respect to what? X. That is u with respect to x to get the derivative. Then v with respect to x to also get the what? The derivative. Now, if you differentiate 5x cubed plus 4x minus 2, you will observe something that this is a polynomial function. And earlier we explained how to differentiate. We said if I have 5x raised to the power 3, for example, the power will come down and multiply the original function given to us. Then thereafter we subtract the power by what? By 1. Now if we apply that on this polynomial function, this 5x cubed, you will see that we have 3 times 5, which is what? 15x squared. Plus 4x. 4x is also a power function. 4x is also a power function. And what is that? You're saying y equals to 4x. And what is the power of x? The power of x is 1. Now, anytime you see x or any variable standing on its own and the power is not visible, so you should know that the power there is what? Is 1. And how do we differentiate this? So we say it becomes 1 multiplied by the original function, then 1 minus 1, which will give us 4, x raised to the power 0, which will give us what here? 4. Because we know mathematically that anything raised to the power of 0 is 1. Then 1 times 4 will give us what? 4. That's how we obtain 4 here. Now, if you check this other one here, minus 2 is no longer there. It has disappeared. It did not disappear. It's because we said something earlier on. I explained that if I'm to differentiate a particular thing and the variable is not there, we are saying that there is no x there. So automatically we say that that's what? A constant. And when we differentiate a constant, it becomes what? 0. And if this is minus 0, we know that anything minus 0 will still give us what? That thing. If I say 4 minus 0 will still be what? 4. So that is why we are not seeing minus 2 any longer. Now, we go back to the next function, trigonometry function. We said cos x. Cos x. From the table of standard derivative and from what I explained earlier on how to differentiate trig function, we said if I differentiate cos, I will get what? Minus sign. And that is the reason why we are having this. Now, you have to recall. The first thing you do, since you have said we are applying or you have been able to identify that the rule present here is a product rule, then the next thing now is to write out the formula that is related, that is associated to the rule that is present. And the formula is the y dx equals to u dv dx plus v du dx. The next thing, after writing out the formula, is to substitute the result you obtain above. Already we know what our u is. We know what our v is, what our du is, and what our dv is. You substitute into the formula given. Our u is 5x cubed plus 4x minus 2. Then our dv dx is minus sine x plus cos x. And our du dx is what? 15x squared plus 4. Now, this is the problem students do have on what to do at this stage. Because if you get this stage wrong, then you miss the mark. Because after substitution, there is need for you to simplify, but in another term, I call it rearrangement. And how do you rearrange? Please look at this. Look at this. I said earlier on that we have these functions, power functions. We have the other one. We have the exponential function. We have the logarithmic, and we have the trigonometry function. Sorry? Now, these functions are important, but there are still some other things you have to take into consideration, like constants and signs. Now, if I'm to arrange it very well, I will check this part before the plus sign, and the part after the plus sign, and check what are the things I can see there. And clearly you can see that on this part I have a power function, I have sign, that's minus sign, and I have a trigonometry function together. So the arrangement is, take note of this, your sign comes first. That's the first arrangement, which is either a positive or a negative. Then apart from the sign, the next thing that follows must be a power function, which I want to write as what? As PF. Please take note. Power function. Then aside the power function, the next thing we have is exponential function, which I can call as what? As EF. Then the fourth one we have, please, the fourth one we have is a logarithmic function. Then lastly, the fifth one we have is what? Trigonometry function. Now, these are the only things we have. But remember, I said something about polynomial that can be constant. That we can still have a constant function. A situation in which is not a polynomial but is a constant. Now, where are we going to fix that constant? That constant comes immediately after a sign. Constant comes immediately after the sign. So take note of that. So sine, constant, power function, exponential, logarithmic, and what? Trigonometry function. That's the arrangement. So if I check this part now, you will see that power function, sine, that's minus trigonometry function. If you check the arrangement, which one comes first? Sine. That's why you are saying sine here. Then after that, what follows? Constant. But I observe that there is no constant here. So I will skip that. I will check what follows again. Exponential. I will observe that there is no exponential. What's the next thing again? Logarithmic. There's no logarithmic. So I will go to the last one, which is what? Trigonometry. That's what we are saying here. Then the next one is the sine. Then I will come to this other part to arrange this other part. What's my arrangement? This trigonometry function and power. Which one comes first? We see that power function is number 2 and trigonometry is number 5. So power function must come before trigonometry function. So with this, you can see this is the result of the derivative of this function given to us, applying what? Product rule. And I hope with this video you will find it so easy and interesting to differentiate or to obtain derivative of any function using product rule. In the subsequent videos, you're going to be seeing how to use the quotient rule, how to apply the chain rule, and also how to apply the logarithmic differentiation rule. And we're going to be merging all these rules together. There will be a question we're going to be solving. We're going to be merging it together on how to apply or implement all these rules. Please take note. I can have, or we can have, more than 3 functions multiplying each other. So in subsequent videos, you will see how we can differentiate such a function where we have 3 functions multiplying each other. Thank you for your time, and please do well to subscribe at the button below. And don't just only subscribe, like the video, comment and share. Don't watch this video alone. Share for others to be beneficial. Thank you.